Hey everyone, this is just a quick review of all the questions off our second quiz of the year. So we're going to start with question 1. Question 1 reads, simplify the following expression, 3/7 minus 3/11. Now, in order to add or subtract fractions, we have to have our lowest common denominator. We don't know how to subtract an 11th from a 7th, so we have to change the fractions into different equivalent fractions that have the same denominator. So remember, in order to figure out what this denominator should be, we have to think about the multiples of each denominator. So if we look at 7, 7 times 1 is 7, 7 times 2, 14, 7 times 3, 21, and so on. If we look at 11, 11 times 1 is 11, 11 times 2, 22, 11 times 3, 33, and so on. If you list out all these multiples, what you'll find is that the lowest common multiple of both 7 and 11 is 77. So we're going to make two new fractions with 77 as the new denominator. In order to make a fraction with a denominator of 7 have a denominator of 77, we have to multiply it by 11. If we multiply the bottom by 11, we must also multiply the numerator by 11 to keep the fractions equivalent. 3 times 11 is 33, so 3/7 is equivalent to 33/7. Now we're going to move on to our second fraction, 3/11. In order to take that so that it now has a denominator of 77, we have to multiply that by 7. 11 times 7, 77. 3 times 7 is 21. And now we simply subtract the numerators. 33 minus 21 is 12 over 77, leaving us with answer choice B. For our second question, it asks us to simplify the following expression. Simplify is just another way of saying solve. So essentially, it's saying solve the expression 4 1/6 minus 2 5/12. Now again, we need a common denominator before we can do anything, but we also have two mixed numbers here. 4 1/6 is a mixed number, and 2 5/12 is a second mixed number. In order to subtract these, we're going to have to change our mixed numbers into improper fractions. So, if I have 4 holes, and each hole is to cut into 6 different parts, that means these 4 holes contain 24 different pieces. Now I also had 1 to begin with, leaving me with a total of 25 pieces that are 6th sized. Do the same thing with our second mixed number. We have 2 holes that are each cut into 12 slices for a total of 24. And we had 5 extra ones to begin with, leaving us with 29 12s. Now we've got these as improper fractions. We're almost ready to subtract, but before we can, we need to find the common denominators again. So, I'm going to list our multiples. 6 times 1 is 6, 6 times 2 is 12, 6 times 3, 18, so on. 12 times 1 is 12, 12 times 2, 24, 12 times 3, 36, and so on. The lowest common multiple of 6 and 12 is, as we can see here, 12. This means we can leave 29/12 as it is. We don't have to change it. It's already got a denominator that is the lowest common multiple of both, but 25/6 we are going to have to change. To get it to a denominator of 12, we multiply by 2. What we do to the bottom, we also must do to the top. We end up with 50/12 minus 29/12. Now 50 minus 29, we subtract our numerators, leaves us with 21 over 12, which is an improper fraction. Now if we look at all of our answer choices, they are all mixed numbers. So we're going to have to take this improper fraction and find its mixed number equivalent. So we look at 21, we look at 12. We think to ourselves, how many times does 12 fit into 21? Well, 12 times 1 is 12. 12 times 2 is 24. So 12 can't fit into 21 2 times. It can only fit in 1. Now, 12 of these 21 pieces are in that hole. That means that there are 9 left over that are not a part of that hole, leaving us with 1 and 9/12. Again, we look at our answer choices and we see 1 and 9/12 is not an answer choice. What should we do? Got to simplify that fraction. We can divide both 9 and 12 by 3, simplifying our fraction to 1 and 3/4. Answer choice C. So now we can move on to our third question. Nice thing about this question, simple subtracting decimals. Subtracting decimals works exactly like subtraction does everywhere else. The only important thing to remember is that you have to line up the decimal points in your numbers. So if we look here, 1.99 is shorter than 4.0025. But our decimals are in line, and that's what we have to do in order to find the correct answer here. Now, remember at the end of decimals, you can add a 0, and it doesn't change the value of the number. Now, we subtract like we always have. 5 minus 0 is 5, 2 minus 0 is 2, 0 minus 9 we can't do, so we have to borrow from our next place. We can't borrow anything from 0, so we're going to borrow the 4, turn into a 3. That would make this a 10, but we're going to have to borrow from there, make that a 9. That is a 10. 10 minus 9, 1. 9 minus 9, 0. Bring our decimal point straight down. 4 minus 1. I'm sorry. Not 4 minus 1, but 3 minus 1. It's 2. Correct answer is 2 and 125 ten-thousandths. Next one again, very straightforward, asking us to solve a couple of different decimal operations. And again, key thing here is to make sure your decimals are lined up when you're performing addition or subtraction operations. So we have to begin here. Parentheses tell us where to begin our problem. We always start with parentheses. So before we can worry about this 4.25 over here, we'd have to deal with what's inside the brackets. And again, you'll see how I'm very careful to keep my decimals in a line. Now, 0 minus 9 cannot do. We have to borrow from our next digit, turn that 5 into a 4. Our 0 becomes a 10. 10 minus 9 is 1. 4 minus 0, 4. 2 minus 0, 2. 1 minus 1, 0. So we end up with 241 thousandths. Now, that is the result of what's inside this bracket, inside the parentheses. So we're still not done. We have to add 4 and 25 hundredths to what we got out of our brackets. And again, my decimals are in line. I add zeros to empty places, and we add just like normal. 0 plus 1 is 1, 5 plus 4 is 9, 2 plus 2 is 4, 4 plus 0 is 4. Bring down our decimal point. Our final solution is 4 and 491 thousandths. So we've gotten through the basic skills-based portion of adding and subtracting decimals. So here's a much trickier problem that combines decimal and fraction together, and you have to decide which one you want to work with. Now, when I see a problem like this that uses both fractions and decimals, I'm usually going to try to convert them to one consistent type of number. So for example, I could make both of these decimals, or I could make both of them fractions. Now, if I look at my answer choices, they're all in fraction. So for me, it makes more sense to take 8 and 25 hundredths and make it a fraction, rather than taking 5 and 1/3 and making it a decimal. So I'm going to take 8 and 25 hundredths. And remember, if you just read that out loud, it tells you already what your fraction is. Now, if I think hard, I realize that 8 and 25 hundredths is unsimplified, because I can divide 25 and 100 by 25, leaving me with 8 and 1/4. So now let's go back to our problem. Miss Riley purchased 8 1/4 yards of red fabric and 5 1/3 yards of blue fabric. How many yards of fabric did Miss Riley purchase? When you think about this, she's got red fabric and she's got blue fabric. And our question is asking us, how many yards of fabric did Miss Riley purchase? So it should become clear that we need to add our blue fabric, that's our red fabric, to our blue fabric to find the total amount of fabric. Now again, we remember in order to add, we need a common denominator. The common denominator, lowest common denominator for 4 and 3 is going to be 12. To make 8 1/4 have a denominator of 12, we multiply the numerator and the denominator by 3. So it becomes 8 and 3 twelfths. To make 1/3 have a denominator of 12, we have to multiply by 4, so it becomes 5 and 4 twelfths. We add those up. 8 plus 5 is 13. 3 plus 4 is 7. Final answer is 13 and 7 twelfths. Next question reads, Miss Hall's class entered a contest to design a flag for American Legion Park. They made 1/3 of the flag blue, 2/6 of the flag red, and the rest of the flag was yellow. It's asking us to find what fraction of the flag was not yellow. So I know the fraction of the flag that was not yellow is red and blue. So first step for me is to think how much of the flag is red or blue. We know 1/3 is blue, and we know that 2/6 is red. So if I want to figure out how much is red or blue and not yellow, I'm simply going to add those two together. Just like last time, we need a common denominator to add two fractions. 1/3 and 2/6. The lowest common denominator is going to be 6. So we multiply 1/3 by 2, and we end up with 2/6. Is already has a denominator of 6. We don't have to change it at all. 2/6 plus 2/6 is 4/6. This is the part of the flag that is red and blue, which is to say, this is the part of the flag that is not yellow. Correct answer choice is D, although you could simplify this fraction and make it 2/3. Last question on the front page. The chart shows the distances from Mr. Maida's house to several places he often walks. So we have a table here that says the name of the place and the distance from Mr. Maida's house, not one. And the question asks, how many miles longer is the distance from Mr. Maida's house to the Civic Center than the distance from Mr. Maida's house to the grocery store? How many miles longer is a great keyword to tell you that our operation here is to subtract. Take a look at how many miles Mr. Maida's house is from the Civic Center. It tells us 7/8 of a mile. If we look at how many miles Mr. Maida's house is from the grocery store, it tells us 3/4 of a mile. So we're going to simply take the distance to the Civic Center and subtract it from the distance by the distance to the grocery store. Again, to subtract any two fractions, we need common denominators. The lowest common multiple of 4 and 8 is 8. So 7/8 can stay like it is. 3/4 needs to be multiplied by 2 in order to make it into 6/8. 7/8 minus 6/8 leaves us with 1/8. Answer choice C. Our next question reads, Samantha went to the mall to shop. She has one $20 bill with her. She bought 2 pairs of gloves for $5.75 each, and 1 scarf for $6.20. The question's asking how much change will Samantha get back. So we know that the change we get at the store is the difference between how much money we give the cash register and how much money we owe the cash register. So we know Samantha gave the cash register $20. And we're going to need to subtract the amount that Samantha owed. So in order to figure out how much she owed, we have to figure out her total. Now she bought 1 scarf for $6.20, so she owes $6.20 so far. And she bought 2 pairs of gloves for $5.75 each. So she didn't get 2 gloves for $5.75. She got 1 pair of gloves for $5.75 and a second pair of gloves for $5.75. Let's figure out how much she owes total. We can do that through some simple multiplication. Now, multiplying decimals works almost exactly like multiplying regular numbers, but remember, we have to be careful about where we put our decimal place at the end. So, we're going to do this just like normal. 2 times 5 is 10. I end up carrying the 1. 2 times 7 is 14, plus 1 is 15. Again, I'm going to carry the 1. 2 times 5 is 10, plus 1 is 11. Now, in order to decide where to put the decimal in our answer, we have to look at our factors. In our factors, there's a total of 2 decimal digits. Down here, 2 has 0 decimal digits. So the only decimal digits are 7 and 5. That means our answer should have 2 decimal digits as well. So she spent $6.20 on a scarf and $11.50 on her gloves. Figure out how much she spent total. We're just going to add that up. 0 plus 0 is 0, 2 plus 5 is 7, 6 plus 1 is 7, 1 plus 0 is 11, bring down our decimal, 1770. Finally, we need to subtract how much she owed minus how much she paid. Now, obviously we can do 0 minus 0, which is 0, but we can't do 0 minus 7. So we have to borrow from our next place. We can't do it because it's a 0. We borrow from here. We make that a 1. We make this a 9, and we make this a 10. 10 minus 7 is 3, 9 minus 7 is 2, 1 minus 1 is 0. For addition, we just bring the decimal straight down. She is left with $2.30 change. Next question asks us to divide 2 decimals and write it in simplest form. Now it's just another fancier way of saying solve. Okay, so we have 251 thousandths divided by 400. So one of the hardest things for people to remember when they're dividing 2 things is what is being divided by the other. The first thing tells us what number we're dividing, and the second tells us what we are dividing it by. So in this case, 2.51, 251 thousandths is what we are dividing into groups of 400ths. Now remember, we can't divide decimal numbers. We need to divide whole numbers. So we do this by doing our little trick and moving our decimal until it's all the way to the right and we have a whole number. So 400 is no longer 400ths. Now it's just 4, the whole number. Now, however many times we move the decimal outside, we must move the decimal inside the same number of times. So now the decimal is behind the 5 in front of the 1. We're dividing 25 1/10 by 4 wholes. And now we divide like normal after we bring our decimal up into our quotient. 4 goes into 2 0 times. So I put an X up there to help me remember that it's a 0. 4 goes into 25, we know, 6 times. We do our subtraction, we get 1. Now 4 doesn't go into 1, so I have to remember to bring down this 1 over here. 4 does go into 11, 2 times to make 8. 11 minus 8 is 3. Now we have no more numbers to bring down, but we can add a 0 to the end of any decimal number without changing its value. 4 goes into 7 times to make 28. We get 2. Again, we're going to add another 0 and bring it down so we can keep up with our division. 4 goes into 20. We know exactly 5 times, and we are finally done. Final answer is 6 and 275 thousandths. Our next question asks us to divide 2 proper fractions. So remember, when we divide 2 fractions, we don't actually end up doing division. We do 3 steps. Keep the first fraction. We change our division operator to a multiply. And finally, we flip the last fraction to find its reciprocal. So what this is going to look like is keep 5/6, change the division sign to a multiply, and we use the reciprocal, the flip of 2/6, to get 6/2. Once you got that, all we have to do is multiply straight across. 5 times 6 is 30, 6 times 2 is 12. Our answer is 30/12. Now, you always need to simplify and always need to make improper fractions into mixed numbers. So I'm going to simplify first. We can divide both 30 and 12 by 6. 30 divided by 12, 30 divided by 6 is 5, and 12 divided by 6 is 2. That's our most simplified improper fraction. In order to get the best answer possible, we're going to convert it to a mixed number. 2 goes into 5 2 times with the remainder of 1. These answers mean the same thing, but we should always write our answer in mixed number form whenever possible. Okay, so this next problem reads, which of the following statements is correct? And it's actually a pretty tricky problem. So all of the questions are asking about the product of 2 different fractions, and we know product means multiply, right? The product is what we get when we multiply 2 numbers together. Now, normally, when we multiply, we're used to seeing things get bigger. But the tricky thing about fractions is they don't always work like that. When we multiply anything by a number less than 1, we get smaller. Which seems weird to think about. How does multiplying make it smaller? Let's give an example. So if we take 5, a big whole number, and we multiply it by 1/2, a number less than 1. Our product is not bigger than 5. Our product is 2.5, which is smaller. So multiplying by a number less than 1 makes a smaller product. So we're going to look at our possible answer choices here. If you take the product of 3/4 and 7/8, it is less than 7/8. We have to evaluate whether or not that statement is correct. So let's take a look. 7/8 is a fraction. I'm multiplying it by 3/4. Now we have to think, is 3/4 less than 1? Well, yeah, it sure is. So our product is going to be smaller. So without even evaluating any of the other answer choices, I can conclude A is true, because multiplying 7/8 by 3/4 is going to make something smaller. Now I can also prove this by actually doing the multiplication. So 7 times 3 is equal to 21. 8 times 4 is equal to 32. 7/8 and 21 over 32. If you compare these two fractions, it is clear that 7/8 is bigger, so the product is indeed smaller, and A is correct. Number 12 was mainly a question to see if you understood the definition of the word reciprocal, but with a little extra challenging twist. So it asks us for what is the reciprocal of 3 3/7. We know the reciprocal of a fraction is the flip of a fraction. So for example, if we're looking at the fraction 3/7, its reciprocal would be 7/3. But we're not just looking at 3/7, we're looking at 3 3/7. In order to find the reciprocal of that fraction, we have to take 3 3/7 and write it as an improper fraction. To do this, we notice that we have 3 wholes, and each whole is made up of 7 pieces, meaning that we have 21 pieces, and we also had 3 to begin with. 21 plus 3 extra is 24 sevenths. This is the actual fraction we need to find the reciprocal of. To find the reciprocal, we simply flip it. 7 is our numerator now, 24 is our denominator. Correct answer is 8. This is a fairly tricky question, and I also made a typo when I was writing the quiz. It should say, what is closest to the value? So, let's read the question correctly. A jar contains 133 pennies. A bigger jar contains 1.4 times as many pennies. What is closest to the value of pennies in the bigger jar? So we know times, fairly obvious, that's a key word telling us to multiply. We start with 133 pennies. We have a jar that's about 1.4 times as big. Now remember, to multiply two numbers together that involve a decimal is really simple. You multiply exactly like normal, and then at the end you come back and check where your decimal should be in your answer. So for right now, we're just going to multiply like normal. 2 times 4 is 12. Carry the 1. 4 times 3 is 12 plus 1 is 13. Carry the 1. 4 times 1 is 1. 4 times 1 is 4, plus 1 is 5. Now we're going to move and multiply our next digit, but before we do, we need a placeholder 0. 1 times 3 is 3. 1 times 3 is 3. 1 times 1 is 1. Add them together. Final answer is 1,862. But again, we have to think about where the decimal belongs. Our factors has 1 decimal digit, so our answer should have 1 decimal digit, giving us 186.2. Now we can't have 0.2 of a penny, so we're going to round it off so that we have 186 pennies. Each penny is worth 1 cent, so the value of 186 pennies will be $1.86. Sorry, had to stop. So we know that $1.86 is the exact value of the pennies that we have. Which of these is closest to that? Well, 171 is the biggest, therefore it is the closest as well. Almost done. This is easily the most difficult problem on the entire quiz. A rectangular patio has a length of 12.5 feet and a width of 55 1/8. Now, I made a typo here. This is an area of 55 1/8, and the question asks, what is the width of the patio? And it tells us that the area is the length times the width. So that means that we had our length, 12.5, and we multiply it times whatever our width is, and we end up with 55 1/8. So to work backward to find our width, we're going to have to divide the area by our length. Now, in order to divide two fractions, we need improper fractions. We can't divide mixed numbers. So, we have 55 wholes that are each cut into pieces of 8. We're going to think, what is 55 times 8? Turns out that 55 times 8 is 440, and then we have 1 extra here. That makes it 441 eighths. Divided by, we have 12 holes here, each cut into 2 pieces. That makes 24 pieces. We had 1 to begin with. That's a total of 25 halves. Now remember, in order to divide two fractions, we have to keep the first fraction, change the division sign to a multiply, and flip our second fraction to its reciprocal. So this looks like keeping the first fraction, 441/8 as it is, changing our division to a multiply, and flipping 25 halves to make it 2/25, which is its reciprocal. Now we just multiply straight across. 441 times 2 is 882. 8 times 25 is 200. We can simplify that by dividing by 2. 441 over 100. Again, we can make this from improper to a mixed number. We have to think, how many times is 100 going to 441? Well, we know 4 times 100 is 400, leaving us with 41 hundredths remaining, which is as simplified as I can get, and that must be the width of the patio. Almost done, second to last question. Chloe had 264 books in his personal library. He donates 4/10 of all these books to the public library. How many books did he donate? So, this is tricky because, again, you have to think, if Chloe had 264 books and he's donating a fraction or a decimal of those to the library, is the answer bigger or smaller than 264? Well, if he's not doing all of his books, our answer must be smaller than 264. And like we discussed earlier, how do we make numbers smaller? Well, we can multiply them by a number less than 1. So a lot of people's first instinct here was to take 264 and divide by 0.4. But think about it, that's dividing by a number less than 1. That would make a quotient that is bigger than 264, which is not what we want. That wouldn't make any sense. He can't donate more books than he has. Instead, the operation here is actually multiplication. Remember, multiplying decimals works almost exactly like multiplying regular numbers. 4 times 4 is 16. Carry our 1. 4 times 6 is 24. Carry our 2. Oh, I made a mistake there. I forgot to add our 1. 24 plus 1 is 25. Carry our 2. 4 times 2 is 8. Plus 2 is 10. If we look at how many decimal digits we have 1. We need 1 decimal digit in our answer. Now, can't donate a sixth of a book, so the closest whole number of books would be 106 books. Last question. We've discussed this many times so far going over this quiz. When multiplying a value greater than 1 by a number less than 1, is the product larger than both numbers? And the answer is no. For the reasons we described. If we multiply by a number less than 1, we end up with a product that is smaller. So we already discussed one example on here. We'll do another. 10 is a number greater than 1. We'll multiply it by a number less than 1, like 1/2. 10 times 1/2 is 5 wholes. 5 is smaller than 10. So when we multiply a whole number by a number smaller than 1, we end up with a product that is smaller. That's it. If you have any more questions, feel free to come to the tutorial. Feel free to send me an email. Feel free to use Remind 101 or ask me in class. Thanks for watching.